Charle's law. This law is also known as Gay's law, and in the previous video we have talked about the Boyle's law. So now in this video we are going to talk about the statement of Charle's law, animation, how Charle's law works, and examples. So first of all, the statement of Charle's law: the volume of a given gas varies directly with absolute temperature. Means if your temperature is increases, it means your volume should be increased, but at given condition your pressure should be constant. So here is an animation. You can see that this is a cylinder where we have gas, and this is a volume scale, and this is a burner for temperature, and these are meters for pressure and temperature. Let's see what is it. So we can see that pressure is constant, but temperature is increasing. As temperature increase, our volume is also increasing here, and when temperature decrease, our volume will also decrease. Here we can see that the graph the graph shows the straight line, means volume and temperature are goes directly. So here let me start with mathematical relationship. So we can see that volume is directly proportional to temperature. As we remove our proportionality, we have a constant, let's say R. V equals to RT. This is the mathematical relationship of Charles' law. Okay, here is another case. Um, let's say this is the volume 1 of a gas at temperature 1. This is the volume 2 of a same gas at temperature 2. Let's say this is the before condition, and this is the after condition when the temperature is changed. Temperature is changed, the volume is also changed. You can see that the temperature is between 200 200 Kelvin, and here the temperature is 500 Kelvin. So temperature change, so our volume are changed. You can This is a change in volume. Okay, so we have to derive the relationship for this situation, just like before Boyle's law. We can say that V1 over T1 equals to R for before condition, and V2 over T2 equals to R after condition. By mathematical equality, we can say that V1 over T1 is equals to V2 over T2. This is the Charles law, another relationship for before and after condition. Okay, now we have examples about it. First of all, we have a 600 ml sample of a gas is heated from 27 centigrade to 77 centigrade at constant pressure. What is the final volume? So first of all, we have data. V1 is the volume of 600 milliliter, and here the temperature 1 is 27 centigrade, but if you know that we have to be converted into Kelvin, so for conversion of Kelvin just add 273 and it will be 300 Kelvin. Okay, and T2, it's 77 plus 273, 350 Kelvin. So now we have temperatures and volume, initial volume, so we can use the Charles law relationship. V1 over T1 is equals to V2 over T2. By putting the values, 600, T1 is 300 is equals to V2 divided by T2. T2 is 350. So it's 2. So 2 into 350 is equals to V2, and this implies that V2 equals to 700 ml. Now this is the answer. And another example actually. A sample of hydrogen gas has a volume of 350 centimeter cube. It's the cube At 40 centigrade, if gas is allowed to expand up to 700 centimeter cube at constant pressure, find out its final temperature. Now, in this case, we have to find the final temperature. And first of all, data, we have given that V1 is 350 centimeter cube. V2 it's 700 centimeter cube. And T1, again, first convert it into Kelvin. So this will be 313 Kelvin. Now relationship of Charle's law, V1 T1 equals to V2 T2. Just putting the values, V1 we have 350 and T1 is 313, V2 is 700, and we need to find T2. Okay, so just first of all we are changing their positions. So this is T2 700 divided by 350, and here is 313, implies that this is 2. So T2 multiplied 2 times 313, and this will be T2 equals to, I think, 626 Kelvin. Now this is the final temperature of the problem. So you have seen that how we have used the Charle's law for different problems. And if you like the video, then don't forget to subscribe my channel and also share this video with your friends.